This video is for class 9 physics, and today we are discussing images formed in a pair of mirrors. That means if a pair of mirror is given to me and object is kept in between them, here we shall study how many images will be formed and what shall be the nature of the images formed. So, going to our first topic, images formed in two inclined mirrors. For an object kept in between two inclined plane mirrors, we get many images of the object. This is our common experience. But this is because the light rays after reflection from one mirror fall on the another mirror, which means the image formed by one mirror acts as an object for the another mirror. This continues till no more reflection can occur on any mirror. When the light ray will go beyond a certain mirror, the object and the images formed by the two inclined mirrors lie on the circumference of a circle, whose center lies at a point of intersection of the mirrors, and the radius is equal to the distance of object from the point of intersection. Let me try to explain this particular statement. Now, let us consider a mirror and another mirror such that they are making a certain angle. Suppose this is mirror 1 and this is mirror 2. Suppose we keep one object anywhere here, right? Then the object and the images created by these mirrors will lie on a circumference of a circle whose radius is equal to the distance between the point of intersection. This will act as the center of the circle, and from here we can draw one circle such that the images will lie anywhere on the circumference of a circle, anywhere on the circumference of a circle. So, this is the position of the images formed, but how many images will be formed, that is a question mark. So, that is our next target, to find out how many images will be formed. This is just the position of the image, right? It can be formed anywhere on the circumference of this particular circle such that the circle has a radius which is equal to the distance between the object and the point of intersection of the mirror. So, let us try to find how many images will be created if the mirrors are inclined at a particular angle. Now, coming to our answer, the number of images formed depend upon the angle. Now, the number of images forms depends upon the angle between the two mirrors. Following two cases are possible. Please listen this very carefully, you might get confused. If angle theta degree between the mirror is such that n equals to 360 degree upon theta is odd. Now, listen this very carefully, okay. They are saying such that n is a number, right. So, such that if we have theta degree in between the mirrors, then a number can be calculated. Remember, this number is not the number of images formed, okay, till now. So, a number will be equal to 360 upon theta degree, okay. Why 360? Because the images were formed on the circumference of a circle. So, that is why 360 degree upon theta degree. Theta is the angle between two mirrors. Suppose we consider two mirrors, right. Suppose we consider two mirrors this way, and there is an angle between them is theta, right. So, if this answer comes odd, then number 1, the number of images is n when the object is placed asymmetrically between the mirrors. Asymmetrically means it is not exactly, for example, this is the angle bisector, it is not lying here, okay. It can be lying anywhere here, up or down this particular line, but not on the line, because this is the angle bisector, right. So, that means asymmetrically, not exactly in between the mirrors, right. then the number of images will be n if the answer comes odd. Remember, if the answer comes odd, but the number of images will be n minus 1, the number of images will be n minus 1 when the object is placed symmetrically. That means if it is falling on this line, if the object position of the object is falling on this line, then only the number of images will be n minus 1, provided this value comes odd. When the object is symmetrically placed, that is on the bisector of the angle between the mirrors. Let us try to understand these conditions with the help of an example. Now, for example, if angle is 72 degree, then 360 upon 72 shall give me 5. Yeah, now this is odd, right? Now this is odd. So images formed will be n equals to 5 for the object placed asymmetrically between the mirrors, and the images formed will be n minus 1, that is 4, if the object is placed symmetrically. For example, if I consider two mirrors, okay, such that the angle between them, these are the mirrors, okay, such that the angle between them is 72 degree, right. Then if you place one object somewhere around here, okay, this is the angle bisector exactly in between those two mirrors, right. If the object, let me change the color of the object, if the object is lying somewhere around here or here but not on this line, then that position will be asymmetric position, right. In that condition, the number of images will be 5 only, because 360 upon 72 is 5. But if the object is lying on this particular line such that exactly in between those two mirrors, then that kind of position of the object is known as symmetric position, right. So under that condition, for this position of the object, the number of images formed will be n minus 1, that is 5 minus 1, which shall give me 4. I hope you have understood for the odd condition. But now if n equals to 360 upon theta is even, the number of images is always n minus 1, it will never be n for all the position of the object, either it is symmetric or asymmetric. So if the angle between the two mirrors is 60 degree, then my answer comes up to 6, which is even. Then the number of images will be 5, either you place it symmetrically or asymmetrically. For example, if these two are the mirrors, such that the angle between these two mirrors is 60 degree, right. Now my answer comes, my value of n comes 6, that is my answer. Now this is even. Now this is the angle bisector. So if you place the object anywhere, either you place the object here on the line or you place at the top or at the bottom, anywhere, for this condition the number of images will be always 5 for this condition, right. So I hope you have understood this particular condition. We shall now consider the image formation in two special cases. So we are not doing for all the angles, but we are doing for two special cases. Let us go to those special cases. When two mirrors are parallel to each other, this is the first special case. Suppose we place two mirrors such a way that they are parallel to each other, right. They are parallel to each other, and when the two mirrors are perpendicular to each other, that means they make an angle of 90 degree, right. They make an angle of 90 degree. So these are the two special conditions which you are learning in class 9. So let us go to the first one. So the first one, images formed in a pair of mirrors placed parallel to each other. When two mirrors are kept parallel to each other, that is theta equals to 0 degree, if they are parallel, so the angle between them should be 0. So then n will be equal to 360 upon 0, which shall give me infinite, So the number of images of an object kept in between two parallel mirrors will be infinite for this particular condition. So for two mirrors kept parallel to each other, an infinite number of images are formed for an object kept in between them. Either you keep it symmetrically or asymmetrically. In figure 7.18, AM and B1 are two plane mirrors placed parallel to each other. So they are talking about this particular figure. Here we shall not go in detail of the diagram, but we'll learn how to draw the diagram. Here I am explaining you briefly, right? So what happens is, actually, suppose you place one object P here in between these two parallel mirrors. So obviously the object will throw light, isn't it? In this direction also, in this direction also, in this direction also, in many directions, right? But according to the book, we are just taking this particular direction here, right? It can go here also, right? Therefore no rays are given for this I dash and I double dash and all. No rays are given. These are for the reflections for this particular rays, right? It will get reflected from here, it will get reflected from here, right? So similar kind of rays will be created, but the diagram will look very complicated. Therefore we are taking just the two rays. Therefore please follow those red color lines here. So when these two rays are coming out from the object, it strikes this mirror, the first mirror A, and suffers reflection. So when it is suffering reflection, obviously it will create one image, which is a virtual image, right? And then after creating this virtual image, the rays will strike this particular mirror B. Now when it strikes this particular mirror B, again it will suffer reflection, because this will act as the object for this mirror here, thus creating another image here, right? So obviously after reflection, okay, the rays will go here, right, as shown. Again these rays will strike this point and this point respectively, thus this particular image will act as the object for the first mirror, that is A, and hence one another image will be created. Thus this will continue, okay, until unless the mirror reflection can, until unless the reflection on the mirror can take place, okay. So therefore when these two mirrors are kept parallel to each other, infinite number of images can be created. So let us learn how to draw this particular diagram. Here I have already drawn this two mirrors for just to save time, okay. So here that is A, mirror A and mirror B, right, and the reflections will be shown, right. So let us watch this particular small clip, and I hope you will understand how to draw the diagram. So here I am placing one object P in between the mirrors, right. Now from this object I am taking two rays such that it strikes the mirror, right. So after taking two rays, I have to show the reflection as well, right. But before showing the reflection, what will I do is I'll just take one small measurement such that my image is already being created, right. So here the distance is nearly 1.7 centimeter, right. So I'm taking 1.7 centimeter for the image also. I shall do the measurement only once, okay. So here will be my first image created, that is I1, right. Now I shall draw the reflected rays and the rays which should be produced backwards together, okay, so that I will not make any mistake while drawing the diagram. So again I am taking the second ray also, because we need at least two rays to complete the diagram, right, for the creation of image. Now my first image is ready. We can do it for the second image also, right. Now either you will measure it or you can take it randomly now, okay. So now I am placing one particular distance I2, any random distance, okay. It is not necessary to measure. In reality, in actual we should measure it, but here since we are doing a random diagram here, okay, we are not required to measure all the distances, right. So I got my reflected ray also, okay. Then Therefore P is creating one I1 and this is creating I2. As I have said that there will be other rays also, from here, right? There shall be other rays also from here, which is not shown in this particular diagram, because it will make things complicated. Again there will be reflection from here, right? Reflection from here, okay, it will reach here, this will reach here, and thus one image is created. Again I have to make another image here, that will be my I double dash, right? And that will keep on going, right? So we are avoiding to make it more complicated, so therefore only 2 rays are taken for the diagram. I hope you are understanding this particular diagram. So this is how we have drawn. Okay, we can continue with the number of rays also. So I am putting the other one I double dash. So I hope you have understood how to draw the diagram. Again in your book 2 more rays are shown. Okay, I could have taken one more image here, right? That shall be my I3. Okay, from that, using the ruler I can produce it forward, and thus I'll get a reflected ray. And from here also I shall draw a dotted line, and touching this line I shall get a reflected ray. This is not required actually, we can draw till here also. Now I hope you have understood the diagram, and now we can go to the second special case. Now coming to the second special case, where the images found by two mirrors placed perpendicular to each other, that means the angle between them, that is theta, is 90 degree. So under that condition, for calculating n, we shall get n equals to 4, which is even, right? Which is even. So for an object placed in between the two perpendicular mirrors, the number of images found will be n minus 1, that should be 3, because this is condition for even. Either you place it symmetrically or asymmetrically. For two mirrors kept perpendicular to each other, 3 images are formed for an object kept in between them, right, as shown by this particular diagram. So here also the diagram, the drawing of the diagram is important, right? I shall explain how will the reflection take place, then we will understand how to draw the diagram. So here if we consider this particular diagram, the object is placed here, that is the P is our object, and for simplicity we are taking only 2 rays, those are black rays as shown in the figure. Now let us consider the images formed. Let us find out the images formed. There are total 1, 2, 3 images should be created, but there is another image P4 also, right? But the problem is P4 and P3 are created at the same point, thus P3 will overlap P4, thus only one image can be seen, either P4 or P3, it will be same, right? So let us see how these images are formed. So considering this P as the object and this OA as the mirror, such that it is perpendicular to BO, right? Now this object will reflect light on this particular surface, and thus can create P1 easily here, right? So P1 is created by a normal reflection from the mirror OA. I hope this is clear, the first one. Let us consider P2. Okay, now as the object is here, similarly this OB can create P2 also in a very easy way, right, like what OA had done. But for that a diagram is shown, 2 rays are taken, it strikes this mirror at these positions, right, and thus reflection occurs. So when the reflection occurs, you can see with the red lines, what happens is we can produce them backwards, thus another image P2 is created here. Now P2 acts as an object for the mirror OA. Thus when this particular image acts as the object for OA, thus it can create another image P3 here. Okay, thus it can create another image P3 here. So how P4 is created, because this P1 will act as the object for OB, but they are formed at the same place, As you can see, all the images, that is P1, P2, P3, P4, right, these are the images formed, and the object all lie on the circumference of this circle, such that the distance between the radius of the circle is the distance between the object and the point of intersection of these mirrors. So I hope you have understood this particular diagram, how does the reflection takes place, etc. Now let us try to understand how to draw this particular diagram. Let us begin. So I drawn a line, okay, first measure of 4 centimeter, remember, and I am drawing another line which is also of 4 centimeter, right. So this will be acting as the mirrors OA and OB respectively, right. So this is the diagram of the mirror. So now what will I do is I will again measure 4 centimeter from the mirror OB and mark one point. So that will be my position of the object, that is P, right. So now as you all know, the object distance should be equal to the image distance in case of plane mirrors. Therefore I am measuring 4 centimeter below the first mirror, that is OA, and I am marking it as P1. So I hope you have understood. Total there should be 8 centimeters between them. So now I am joining these two particular points, dots, with a dotted line. Now again, before drawing the rays, I am taking 8 centimeter from this particular point, and I am marking one more point such that I shall get P2, right. Now this will act as my P2, that is the second image, okay. So this will act as P2, that will be my second image. So now similarly again I can measure 8 centimeter and mark P3 and P4, right. Mark P3 and P4 as they are formed at the same point. So I am just showing one image, that is P3, okay. P4 I hope you can see it afterwards, okay, when I move the page. Now I can join the dots, right, all the 4 dots I can join, right. So then I got my object position, image position, etc. Then it will be easier for me to draw the reflected rays, right. If we start with the reflected rays, they might not fall on the circumference of a circle, because the reason is actually while drawing we might not follow the laws of reflection. We have to use the protector also, then we shall get a proper diagram. But it becomes complicated to use a protector, therefore we can draw just using the ruler. So thus I got my figure somewhat. The internal part of the figure is ready. Now what we can do is I am starting with the incident rays which is falling on the mirror OB, right, which is falling on the mirror OB. So these are my 2 incident rays. Try to make it as low as possible to show the reflection, right. If you are trying to keep it at the top, then the reflected rays might go away from the mirror OB. So therefore it is better to keep the reflected rays at the lower portion. I am talking about this particular lower portion, okay, this lower portion here. If the incident ray was striking somewhere around here, then it will be a little bit difficult, okay. So I hope this is clear. So now I am drawing my reflected rays also, that falls on the mirror OA, right, that falls on the mirror OA. So I hope this is clear. Now we can draw our reflected rays for the image P3. So always start from the image, it becomes easier, right. It should be dotted line, but because of the position of the camera I am finding it difficult. Then the second reflected ray, okay, from the point P3. Okay, So my reflected rays are ready and my position of the image is also ready. So my figure is ready. You can use a compass to draw the circumference of a circle, but it is not necessary to draw the circumference of the circle. So now I can mark the mirrors, that is A, B, and there should be O here. I hope it is understood now. So this is the complete figure, right? So this much for this particular diagram. Then we can go to the next topic, which is uses of plane mirror. Uses of plane mirror. The plane mirrors find the wide applications in our daily life. Some of the applications of the plane mirror are given below. Number one, most common and wide use is as a looking glass. I hope we use this, you all know, right? The looking glass, right? The use of looking glass. Number two, it is used in the optician's room to increase the effective length of the room. It is done by keeping a plane mirror on the front wall and the signboard on the opposite wall, just behind the patient. For the patient, the signboard is at the nearly double the length of the room. So that's how it is used, okay, just to give us a false effect of the size of the room. Number three, it is used in the barber shop for seeing the hairs at the back of the head. Here, two mirrors are facing each other, are fixed on the opposite walls at the front and at the back of the viewer. Number four, it is used in periscopes also. Two parallel plane mirrors inclined at 45 degrees with the vertical walls are kept facing each other in a periscope. I hope you know what periscope is. I think we are done in class 7 also. In a kaleidoscope, three plane mirrors are inclined each other at 60 degrees such that they make an equilateral triangle. If small color bangles pieces or pulses are kept between the mirrors, beautiful hexagonal patterns are seen on rotating the tube. Then we have last one, solar heating devices such as solar cookers, solar heater, etc. A plane mirror is used to reflect the incident light rays from sun to the substance to be heated. In fact, we can use curved mirrors also. That is our next topic, shall be discussed in our next video. This much for this video. Thank you so much.